So we did a few different designs, more focused on the coral mechanism, or the coral component. We didn't really work at all with the algae. So start with how we want to load. We were looking more at requiring a few different things. We have our must-haves, our should-haves, and our could-haves. So we must be able to get the coral from the human player. We have to be able to get the level 1 coral, and then also be able to score in autonomous with that level 1 coral. We should be able to get level 2 and 3 on the corals, and also climb on the shallow cage. And then we could do the algae lower, the level 4 coral, climb deep, try to get some more auto scoring, and also intake some algae. But those are lesser important than the must and should haves. So we start with loading from the human player station. So there's two different ways that can be loaded. It can be loaded where it's like kind of rolling down the slope, or it can be coming down at the other direction where it's down a nice path. So we're looking at both directions. We have some designs for different things, but it seems that when you go down with the straight path rather than it loading, it's more accurate and it doesn't wobble so much.
Cool. So one of our first designs that we came up with was an addition to the kitbot design. This is a special hook that you can see in the original kitbot design. The coral rolls down the ramp here. This hook would stop it from rolling down the ramp, and it would be able to extend up and place to the side. So you can see it here. You would be able to load from the human player station here and deliver into level 1 as normal, or right here, there would be a hook, if you can imagine it coming out of the side and scoring off to this side of the robot. So you can score in this direction or this direction or this direction, one of these two directions. And then one of the main drawbacks with this is that in a tank bot, it would be hard to side up to a scoring element precisely, or to side up to a human player station. And then we did a little bit more permutations with angles here, trying to figure out what angle we would need a claw to be at to grab something off of a ramp, and then score on the 35-degree posts. However, if we go to our next one, we started looking at, we don't need the claw to necessarily be at an angle to score on these posts. Because they're at 35 degrees, we can drop the coral onto this post dead on, and it should even itself out. When we do that, we came up with another design for a top attachment that works kind of like a bucket. The bucket can turn all the way over and dump it straight down onto any of the posts. And depending on how high that bucket is, it could go to L2, 3, or 4. If we wanted it to be static state, there's also a way we could work the geometry so that it could go straight down onto level 2, and it could angle onto level 3. You can see that right there. It goes straight down or angled. And then Melissa.
And our other design for lifting the coral is more of an elevator design. So we have some different stages, and those will come up at an angle so that we can reach all of the different level 2, 3, and 4 for the coral, as well as probably we'll be able to drop it down into the trough. But this is one of our concerns is just the strength of it at an angle with the pretty hard PVC pipe at the end. So we added some sort of structure to it at the bottom to keep it in place and hold it up. I think that's very helpful. Plus, with it coming down at different angles, so if we were to send it down the human player station at a straight down, then we have a nice as the arm is down here, there's a holder thing where as the thing comes down, it'll hit it and hold it correctly in the grabber. That should put it nicely in its right place, and then this angle can change based on where we would like to place it.
Okay, in the end, out of the climbing mechanism we have here, so I have two candidates here for cage number 1 and cage number 2. And the first thing to note about that is that this is a cage, and for top section here, it's anchor, which is highlighted in green is the game piece menu. And based on the rule, this section cannot be touched by the robot, so you can only clamp in this cage through this wall and the bottom side. So for first options, we are thinking have some extension arm here. You clamp the whole cage tightly, and we have some kind of wedge here or high gear ratio reduction gearbox to lift the whole robot up. So in this case, the robot will be climbing up and you will be lift off the things. Because center of gravity, the whole thing may sway a little bit back, but based on calculations, I think we are able to clear the ground over here. That's for option 1, which is clamp the whole cage. For option 2 is that, for example, if this is a cage, we will slide something inside, and in this time, we will have the vertical linear lifting for the mechanisms, where we have high gear reduction gear here, pulling the whole robot up by holding the bottom piece here. The downside is that this thing is very close to the ground over here, so maybe this method only works for shallow climbing, but not for deep climbing, but this requires a lot of more testing to find out. So this is the candidates we have for climbing mechanisms. Okay. I think we're done.
Okay.